Welcome back to Math 104. Here are some fundamental definitions that we will use frequently in this subject. An experiment is an action which can have one of several possible outcomes. So experiment is a technical term and outcome is a technical term. For example, the experiment is to flip a coin twice and note the sequence of heads and tails. If that's the experiment, then what can happen? Well, one thing that can happen is that you get heads, heads. Okay, that's one outcome. Heads, tails. That's another outcome. Tails, heads. That's another outcome. Tails, tails. That's yet another outcome. And, if you think about it, these are all the outcomes. If you can think of something else that could happen when you flip a coin twice and take note of the sequence of heads and tails, I challenge you to tell me what that is. Okay, we presume here that when you flip the coin, it can't land on its edge. Right? Each individual coin either lands heads up or tails up. So these are all the outcomes. We will see a little bit later in the course how we can predict in advance that there will be 4 outcomes for this experiment. For the moment, we're just listing all of them. Now, it's important that on each performance of an experiment, one and only one outcome occurs. Right? So we start out knowing what the experiment is, we perform the experiment, and exactly one of these 4 things happens. Another important point here is that when we list these outcomes, these 4 outcomes for the experiment of flipping twice, no one is saying anything here about whether the coin is fair or not. Whether it's fair, or it's weighted to favor heads, or it's weighted to favor tails, these 4 outcomes are all the possibilities. These are still the only things that can happen when you flip twice. The idea behind calling them outcomes is that the outcomes are the most basic possible results of an experiment, the most basic things which can happen when the experiment is performed. Notice also how we can describe each outcome by a quote-unquote word, not that you could really pronounce it, but in a certain sense, HH is a word, it's a 2-letter word, from an alphabet consisting only of the letters H and T. HT is a different 2-letter word, and it describes a different outcome of the experiment. TH is yet another word, TT is yet another word. If we flipped 3 coins, we could describe outcomes by 3-letter words, such as HHH or HTH, etc. These would be outcomes for flipping 3 coins. But the letters available to describe coin flipping outcomes are still H and T. If we flipped 10 coins, we would have 10-letter words, still using only the letters H and T. Our next term is sample space. This is a technical term. It's been in use for a long time, and it's too late to change it. I realize it's not very suggestive, but here's what it means. The sample space of an experiment is the set of all its possible outcomes. If you're not familiar with the word set, think of a set as just a list of items in no particular order. So for example, for the experiment of flipping 1 coin, whether fair or not, and using H to represent heads and T to represent tails, the sample space is the set of these 2 items. So one outcome is just H, the other outcome is just T. If you wanted to write this as If you wanted to write this as T followed by H, this is just a list of separate items here. So here the order does not matter. For the experiment of flipping 2 coins, whether fair or not, the sample space, as we have seen, is the set of these 4 outcomes, these 4 words. Notice the use of curly braces to enclose the members of a set. That's one of the ways of signifying that we're talking about a list where the order doesn't matter inside that list. It might be convenient for our own organizational purposes to list the outcomes in a certain order. For example, the first way we listed the outcomes for the 2-coin flip experiment was actually in alphabetical order, and that might be convenient for our own organizational purposes, but if you wrote in this other way, in this other order, that's equally valid. Now, we have to be really careful here. What I just said about order not mattering applies when you're listing out all the outcomes within the sample space. However, by contrast, within a single word, that is a single outcome, the order is very important. When you contrast heads-tails with tails-heads, those are two physically different occurrences. And in case that's not quite believable or vivid enough, imagine that we actually have two obviously physically different coins. Say one of them a penny and the other one a dime. Heads on the penny, tails on the dime is clearly a different outcome from tails on the penny, heads on the dime. Okay? Those are clearly two physically distinct outcomes. Right? That's a way of helping to see that heads-tails really is a different thing happening than tails-heads. These examples already illustrate a very important point for the entire course, that whenever you need to think about a certain experiment and solve problems about that experiment, the first thing you must do is to understand what all the outcomes are. So given an experiment, always think, what are all the possible outcomes? How can I describe all possible outcomes? Listing the outcomes explicitly is often helpful, and representing them as so-called words in a certain quote-unquote alphabet is also very useful. For example, if the experiment consists of flipping a coin 10 times, our favorite experiment from recent videos, then the following outcome could be written as a certain 10-letter word. Heads, heads, so HH, T, 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 H, T, T, H. Okay? So do not try to pronounce this. Sometimes there are actually too many different outcomes to list them all by hand. For example, in this experiment of flipping 10 coins, there are already more than 1,000 different outcomes. You might not believe that at first, but we'll see why it's true. Understanding how to describe the outcomes as words in a certain alphabet, as we've done here, is still very important, and it really helps us to think about the experiment. Before going on to the next video, consider the experiment of selecting at random a family with 3 children and noting the birth order of boys and girls. Your task is to find the sample space, in other words, to write out all possible outcomes of this experiment. You can represent each boy by the letter B, you can represent each girl by the letter G, and you can represent each 3-child birth order with a 3-letter word consisting of B's and G's.